This video covers section 4.4, solving direct translation, geometry, and uniform motion problems using systems of linear equations. Objective 2, model and solve geometry problems. For this objective, we will need to use the practice 2 problem. The practice 2 problem says the length of a rectangle is 4 feet less than 3 times the width. Express the length of the rectangle in terms of the width. We draw a rectangle, and the length of this is 4 feet less than 3 times the width. So if W represents the width, then the length of this rectangle will be equal to 4 feet less than 3 times its width. The width is W and the length is 4 less than 3 times that width. Example 2. Perimeter problems. For perimeter problems of rectangles, we need to remember that with a rectangle, the perimeter of this rectangle includes 2 of the L's and 2 of the W's. And for example 2, it says that a rectangular field has a perimeter of 400 yards. All right, so our perimeter is 400 yards. And the length of the field is 3 times the width. So we'll let W be the width. And then our length, which is L, will be 3 times the width. The length is 3 times the width, and the width is W. So now we use the formula for perimeter as 2L plus 2W, using P to be 400. We're going to take twice the length plus twice the width. W is the width, 3W is the length. Now we have an equation in one variable. 400 equals 6W plus 2W, giving us 8W. Equals 400. We divide both sides by 8. Gives me W equals 50. Now the length is 3 times W, which tells us the length is 3 times 50, which is 150. So the dimensions or the length of the field is 150 yards. And the width of the field is 50 yards. Simple check is the length is 3 times the width. That's obvious. And then the perimeter is 400, which is found by taking 2 times 150 plus 2 times 50, which is 300 plus 100, which is 400. We have a 150 by 200, sorry, 150 by 50 rectangle. Example 3. Supplementary angles is the concept of this problem, and supplementary angles are two angles that add up to 180. So we have the smaller angle and we have the larger angle. We know that the larger plus the smaller must be 180 degrees. That's the first equation. L plus S equals 180. But we're told that the larger angle is 16 degrees less than 3 times the measure of the smaller. We're told that the larger angle is 16 degrees less than 3 times the measure of the smaller. There's my second equation, and there's my first equation. So we solve by substitution. We substitute 3s minus 16 in for L. The sum of the larger plus the smaller equals 180. The smaller is S and the larger is 3s minus 16. So giving us 3s, 3 times the smaller minus 16 plus the smaller is 18. And I just realized that should be a 180. 3s plus s is 4s. Minus 16 is 180. We add 16 to both sides, and we get 196 equals 4 times s. Divide both sides by 4. Gives us s is equal to 4 times 4 is 16. Remainder 3. 4 goes into 36. 9 times. Smaller angle is 49 degrees, and the larger angle is 16 less than 3 times the smaller. 3 times the smaller, $147 minus 16 is 131. So the larger angle is 131 degrees. Practice 2 is for you to try rectangular parking lot with a perimeter. I encourage you to press pause on your video, work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out for you. A parking lot has a perimeter of 125 feet. The length of the parking lot is 10 feet more than the width. This is my length, and this is my width. We label them L and W. And it tells me that the length of my parking lot is 10 feet more than the width. And the perimeter of 125, and using the formula P equals 2L plus 2W, gives us 2L plus 2W equals 125. So with the L equals W plus 10, we solve by substitution. We get 2 times L plus 2 times W equals 125. 2L is 2 times W plus 10 times or plus 2W. We distribute the 2 across and get 2W plus 20 plus 2W equals 125. 2W plus 2W is 4W. And so we solve this by subtracting 20 from both sides. That gives us 105, or 4W is 105. We solve for W by dividing by 4. And we get W is equal to 4 goes into 105. 26 1/4 times. And now the length is 10 more than the width. So that tells us the length has got to be 10 more than that, or 36 1/4. So I'd like to double check this by taking 2 times W plus 2 times L, and that should be equal to 125. 2 of the W's, 26 1/4, plus 2 of the 36 1/4. That's going to give us 52 1/2. 2 times the 36 1/4 is going to be the 72 1/2. 52 and 72 is 135. Did I make a mistake somewhere here? 4 goes into 10 2 times 4 is 8 remainder. Let's see. 26 1/4 plus 36 1/4 gives me 12, 3, 4, 5, 62 1/2. 62 1/2 plus 62 1/2 gives me 124 plus 1 is 125. Yeah, there's the mistake right there. 2 plus 2 is 4, 7 plus 5 is 12, 124, 1/2 and 1/2 is a whole, and 125. Okay, so yes, those fractions, they get you every time, but it all works out in the end. So the width is 26 1/4, the length is 36 1/4, both of those being measured in feet. This concludes the video for section 4.4, solving direct translation, geometry, and uniform motion problems using systems of linear equations. Objective 2, model and solve geometry problems.